Hey folks, so we're continuing the intermediate Python series where we're making a Dripbox, which is our Dropbox clone that we can add stuff to and share things across the network. And we're going to be doing some more like really good, solid intermediate Python practices in this, including more asynchronous stuff. In fact, that's the bulk of this video is going to be about making an actual background process that's not just spitting out random numbers like this thing does. We're going to make our real background process now. And we're going to, once again, touch on TinyMongo, because it is a great way to stuff all of our data into a little database. But we're going to get really crafty with it, and we're going to do things that it can't do on its own. So we're going to actually solve TinyMongo's last remaining, I don't want to call it a bug, but it's missing a feature, and we're going to add that feature. But before we do any of that, I want to show you a really good intermediate Python practice, which is to keep a to-do list. When you notice things that you need to do, but you're not necessarily working on the code right now, write it down in a little to-do file. In this case, I saw a few things that needed working on when I was doing the editing for the last video. So let's just do these real quick. Like these are going to be super fast. We got them nicely organized. So I need to use set in TinyMongo's update function. So in here, I'm just giving it the ID to tell it this is the document I want you to update, because I'm saying update, and then ideally this would actually be update 1, but I don't actually know if update 1's in TinyMongo. We'll just leave that as is. The thing that is really important here, though, is I'm just passing in a document rather than setting a specific field of a document. So this works in TinyMongo, but it does not work in PyMongo. And I want this to be educational so that you can take these skills and transfer them to bigger projects using PyMongo. So the correct way to do this is actually to use a, forget what this is called, like a high-level operation, where we set, we're saying this is the thing we want you to do, and there's other things you could increment or decrement, or in PyMongo you can add to set, but there is no add to set, which is the feature we're going to have to add on our own later. But you want to use this set specifically when you're trying to change just one or a few things in a document, because if you were to pass it the way it was before without this set, it would actually overwrite the whole document and just have that one thing that you've got in there. So if there was a whole bunch of stuff in there, you just lost it all. So use the set to say, I want you to update this specific thing that I am referencing with this new value instead of fucking it all up. So we have done that now. Next is to fix the cache path. So in this was a goofy mistake, because I was talking about how we wanted to normalize the path across all operating systems, because we're getting into weird issues with the way it was taking Windows directories and putting slashes kind of in the wrong direction. But then I used this right here where I'm giving it the wrong direction for Windows. So this will work fine on Mac OS and Linux. It worked fine here, but it's not going to look neat in our database, and that's the specific thing that I want to address. So we're going to norm path this whole thing right here, and that's all we had to do to fix that. Now it's going to take this / and make it a backslash if the OS that this is being run on is Windows. So we've fixed that problem, and now we want to make sure that the user cannot share the same file multiple times, because that could make a big mess out of things. Like we're doing all these things to check about, is the file actually there and stuff like that. We should probably also just check real quick if this share path is in the database. So Dripbox db shares find one share path. So if this returns with anything, then we know that we've got a duplicate file here. So we should tell the user using our alert share that this is a duplicate share, and return false so it doesn't do any of these things and try to make a duplicate cache or anything like that. So we've now added that feature, and you'll notice that as I was going through my to-do list, I'm adding these little symbols, and this is just my own kind of way of doing this. Some other developers also like to do this where I'm putting a star here for like, I don't know, this is just not really a feature, not really a bug. I just did the thing. This minus sign for I removed a bug, and plus is that I've added a feature. So this can be helpful when you're doing commits to Git. So you can say, okay, these are the things that I did in this commit. But let's get to the actual like stuff I wanted to do in this video, which is really build out a whole caching system that's checking periodically to see if our local files have changed. Because when this is going to be running in a network, we're going to have a lot of different computers who are going to be talking to each other, asking each other, okay, has this file changed? Has this file changed? And we need to be able to make that determination. Has the local file that we're caching here, has this been updated? And do we need to make a new cache and then alert everybody else in the network that we've got a new version of this file? So that's what we're going to build. But we need to make sure that our caches include the details that we're going to need to do that. So we're going to use two different methods for checking to see if a file has actually been updated. The first is really easy and gentle on the CPU, where we're just going to check the modified date. And if the file's last modified date has changed, then we're going to do a deeper scan using a MD5 checksum or hash to let us know if the file's really changed. So let's now start saving that into our cache data here. So the modified date's really easy to get because the os.path module has so many useful things, including get mtime, which is the one we need here. So we just give it the share path, and this will give us a timestamp, kind of like the way we're doing this cache time here. I can show you that real quick here. Import os, os path, get mtime. So yeah, the background thing here was last modified at this second. So we're going to get a nice, easy to use little thing from that'll just stuff nicely and neatly into this. But the other thing here right now, we need a cache hash. And to do this is going to be like a whole big process. So we're going to need to create, to keep it neat, we're going to create a whole new file. We're going to call this file management. All right, so I know that this is going to need the OS package and shell util and datetime, and we're going to be using hash lib, which includes a whole bunch of great stuff. Let me show you it. So the one we're going to be using in this is MD5, which if you've done anything with computers, you've probably heard of before, because this is the thing that we do file checksums when you're transferring a file over the internet and you want to know if the file you got is either corrupt or like maybe the download went bad or compromised. Maybe somebody did a man-in-the-middle attack and you gave you a bad file from a shady server. You would do an MD5 check to see if this is the same exact file that you got from the person who created the file. And the way it does this is really damn clever. So you just put anything into this algorithm here, and it needs to be encoded, so it needs to be a bytes object. It'll take that and it'll run those bytes against its internal algorithm and spit out a hex digest saying that anything as bytes equals this, and it'll always equal that. Like whatever you're putting into this, it's an algorithm, so you always get the same output, right? Like if you had x plus 2 equals whatever, right? Then whatever is going to always be the same thing because plus 2, it's just math, right? So this is just math. It's fast math to know if the thing that we're putting in here has changed. So if I change anything to something, now it's giving us a different value. So remember, it was giving us the same value here, but we now got a different one here. So we can do the same thing with full files. And although it probably seems silly that I'm asking what's the digest, like you expect that to be a smaller thing than the thing you're putting into it, right? And something's way smaller than this huge hex string. But if we give it a huge file, we'll get a similar size, like the same sized hex string. So this is a good way of representing things. So we need to open a file, and I'll just use our background py as f. Oh, and remembering to read it as a bytes object. We do the same thing, hash lib MD5, and actually let me make sure I print this. So we're just sticking file, which is F, in here and reading it. And then we're going to ask it to tell us what the hex digest of that file is. And we get this result. So this big file is represented by this small string. And this is really, really handy because it doesn't matter how big the file is, it's always going to be represented by this sized string to let us know if there's ever any changes. So if I make a change to this, like say I add some more lines to it, as I click away from PyCharm and PyCharm saves the file, I can now rerun this and I get a different string. Like I didn't actually add anything to it, but the file did change with all these extra lines in it. It's basically just a bunch of carriage returns that happened here. And that changed the way that the algorithm saw this file. So we know that this file has changed. There's a small catch to just throwing files into this though. If we throw in a really big file, and for this example, I'll use the last episode, this is not going to work. So we get a memory error because that's a huge file. So let's make a hashing function that's going to be intelligent enough to handle big files, because we're obviously not going to want to have some sort of limitation on that. So we're going to make a get hash function that'll take a file, and we're going to open that file. We're read byting as F. And now we want to create a instance of this function rather than trying to use just this function as is, because we're going to be stuffing this into a loop. So while true, we want to make a buffer by reading a portion of this file. And you see it's giving me an optional parameter that's an integer, and this is the length of the buffer. In this case, I'm going to do 8192, which is just kind of a default. I've tried increasing and decreasing this. It didn't seem to make any difference. So we're going to give it this buffer here. So it's just going to read the first 8,192 bytes of this file, whatever the file may be, and stuff that into a little variable called buffer. And we're going to put that now into our MD5 instance using the update method. Now since this is a loop, it's going to stuff that buffer in and then get a new bunch of data. So if the file is longer than 8,192 bytes, it's going to get the next 8,192 bytes and stuff that in the buffer and stuff that in the update of the MD5 instance. Now, what happens when it gets to the end? Well, we got a handle for that. So if not buffer, then the buffer's empty and we need to break out of this loop. And once we've broken out of this loop, we want it to tell us what the MD5's hex digest is. Let's test this out now. Make sure it's all pretty. And now from Dripbox, file management, import get hash. And now if we get hash on that large video file, it's taken a while. It's not giving us a memory error, but it took a while and it gave us a result. So you see that takes a really long while when we're using a big file. So this is a great candidate for asynchronous stuff. Like we just put async right here. Oops. We spell async correctly. And now if we import async IO, at the bottom of this loop here, we'll just put a await async IO sleep 0. So this means that we're not really like waiting for any great time, but we're backing up just long enough for any of the other processes of our sub coroutines of our app to do its thing without being locked up waiting for this hash. There's a problem though now, like because we've made this function asynchronous. If we try to stuff this in here, into a non-asynchronous function, we're going to have problems. But that's exactly what we've got to do, because this is where we need it, right? So if we await the... oh yeah, we need to actually import that. Dropbox file management. Get hash, and we give it the share path here. We need to make this function asynchronous, but because we've made this function asynchronous, we need to make sure any place that we're calling the add share is awaited. You see how this kind of takes us down a rabbit hole. So we did that in the GUI, where we're add share here. So now in between the if and the function that we're doing, we need to add this await here. And because this is asynchronous, we're finally caught up. Everything should be asynchronous now. I kind of want to test this, but I also don't, because like let's just keep moving. We're going to return the MD5 hex digest rather than print it here, because that won't actually be useful. So now this will give us a nice little itty bitty string out of a great big file that we're going to have here as a variable that we're going to stuff into our cache list. So remember, we're keeping a list because we are going to have multiple caches of files. So let's pretty this up a little bit, because right now it's not pretty. I like to try to keep the variable declaration and the variable usage inside of these database inserts to be lined up nicely, so that you can look at one and see that it's matching up with the other. So I'm going to say, since cache time is the first one, cache time is going to be the first one here, and cache modified equals cache modified, and cache hash is cache hash. And you notice I'm saying cache and not cache, because I know how to fucking pronounce cache. It's a really important distinction that everybody should learn. So now we've got this neat list that we're stuffing into our database for every time we add a share that's going to have the modified that we can check against. And if that modified is changed, then we're going to want to check the hash of the file as well. So let's do that. Like, we're going to actually make the thing that's going to be doing the checking now. So this is going to be asynchronous, and we're going to check local files. And we're going to go through every single share. So for share in, I need to import Dropbox. Yeah, we don't need to specify anything here. We just want all of the shares. So find. So now we're going to want to take each share in our shares database and do some checking on it. So the first thing that we're going to want to do is, I guess we could do this right here. I'm trying to decide how to do this neatly. Let's just do it right here for now. So if the share, and now I got to show you a list trick. Okay, so remember that the caches are going to be a list. There's going to be multiple caches in there. We can't just say cache 0 or cache 0 and then expect to get the latest one, because that's not going to be the latest one. And if we put cache 1, it might be the latest one, but what if there's only one cache in this file? Like, if it doesn't have a cache 1 to grab, then it's going to throw an error. So the way you get the last object in the list is an interesting little trick here. So we can say that this list is 1, 2, 3, 4, 5. And my list, -1, gives us the last part of that list. So we can do that trick right here. So it doesn't matter how big this cache list is, it's always going to give us the last one, which is going to be the latest one. So if the share cache, and then we can call into this with the way that we've assigned this, we can say, okay, well, is the cache modified? Is the thing we're going to be looking at first here. if this does not equal, here we're going to do the get m time for the path of this file. So share path. So if this doesn't equal it, let's print it right now so we know that that doesn't work. Share has been or share date or modified date has changed for, here we'll just do share file name. Okay, so if this is the case, then we also want to now check if the hash has changed. So if share cache -1 cache hash does not equal, and now we're going to get the hash of share path. Okay, so if our hashes don't match, then we've definitely got a modified file. So hash has changed for share file name. So what do we do if this happens? We're going to need to make an entirely new cache of the file, right? So this file has changed. We need to make a new copy of it in our cache so that when we report that this is changed to other computers in our network that may be interested in this file, we'll have this cache for them to grab instead of trying to grab it from this file that might at any time be changed or edited or being used right now. So let's make a way to do that, right? So we basically have to do all of this again, right? Where we get the file name and the cache, and we have to do all of this where we're copying it. We have to do all this all over again. And if you're ever doing all of a bunch of code over again, that means you need to take all that code and make a function. So let's do that now. So we're gonna make a this needs to be asynchronous because it's got the hash, the get hash in it. So async def create cache, and this will take the share path, I guess. Yeah. All right, so we're doing all of the same stuff. We don't have to call this get hash the same way we were doing before, but we do have to await it. And now we've got all of our copying and hashing and checking. We've got all of this right here in this nice, neat place. But now we got to return this back to where we stole it from. So let's return all these things. So we just do file name and cache time. It's important to note which order you're returning things in. Like you can return multiple variables from a function, but you need to pay attention to which order that they are in, because if you're trying to grab them in some other order, you're going to get all kinds of confused. So let's not do that. Let's make sure we're returning all these things that we need in this order, and we're going to really make sure that we do that by just copying that now and going back into our database file here, and we're going to say that all of these things which we need right here are going to be equal to await dripbox file management create cache using this share path. So we've got all of this stuff now happening in this one function, and it's all going to, like you see all the red stuff disappeared as soon as I got all of the variables lined up nice and neatly. So here it's checking to see that the copy actually worked. Like, did we actually create a cache? And if it didn't, then it failed. We're not doing that here because we don't have a good way of expressing this to people if we come to the create cache from here, because we're going to create a cache using this. We don't have a mechanism for expressing that to people. So this is something we might want to do in the future, and this is an excellent time to make a to-do for ourselves. So I'm going to do to-do, and you can't see this because I actually use the to-dos in PyCharm to bump out this. Like that's what's keeping my head from obscuring whatever's going on down here. But there's a thing in PyCharm that's that keeps track of to-dos for you as well. So just by doing this comment space to do, maybe we should check if this copy worked. All right, so we can come back to that if we decide to. So this is all working again. Now we're back to here where we know that we've got an update to this file that we need to make a cache of. So let's make it. Let's create a cache, which is going to return all of these things. It's going to be a real mess inside of this. Yeah, let's make this a separate function here. Once again, this has to be async because it's going to be calling another async function. Call this add cache, which is a slight differentiation from create cache, but we need to specifically add a cache to an existing thing. And in this case, we're going to take the whole share, like the whole database entry for this specific share file, and we're going to pass that in here because it's going to have a lot of useful information for us. So we're going to need to actually do basically the same thing that we're doing in the database thing, or we're just going to say that the file name, cache, and cache modified, cache hash, and cache path are all equal to create cache of shares share path. Okay. Now we don't actually need the file name, but we do need to specify it here because that is one of the things that this is returning. Like you can't just pick and choose. Like we honestly only need these last 4, but because this is returning 5 things, if you only grab 4 on the other end, it's going to break. So we have to put that there even if we don't need it. So doing this just by this process of saying add a cache for this share. Oh, we need to await this. And we need to await this too while I'm thinking about it. Just by saying this, it will create the files and stuff, but we need to then take all this data and stuff this into our database as another one of these little documents inside of our cache list. So I just copied and pasted that. I'm going to paste that because it's going to make life much easier. So we're just going to say this is the new cache. We'll call it new cache. And it is equal to this dictionary here. And now we need to add this to the shares cache list. In PyMongo, this is really easy. I'll show you that. So we just do db shares update. ID is share ID. And we would say add to set, and that is cache. Just add the new cache to this set because it's referring to the list as a set. So this would work. That would be all we would need to do. But there is no add to set in TinyMongo, so we can't do that. We're going to have to fake it. And fortunately, that's fairly easy to do here. So we're going to make a new cache. We're going to say caches is equal to share cache. Shit, this is getting confusing because there's caches and cache and new cache. And we're going to assign this as, let's call this cache list. All right. And that is the cache of the share, which let me pull up the thing so you can see it here. So that's just, it's whatever's inside this. It's going to be the whole list. Every single entry is going to be in that list. So here we're going to assign that all to this, and we can now just append to the cache list, or because this is a list, we can just append to it the new cache. But we probably don't want to save a whole lot of copies of the same file. Like I think a good limit is 2. Like we only want the most recent cache and maybe a previous version so that we can go back to that if we need to or something. So let's only save 2 copies of a file. And we need to now check to make sure that we don't have a duplicate. So if the length of the cache list is greater than 2, and remember that length it starts at 1. Arrays and lists start at 0, but length starts at 1. So if there's 2 items in there, then it will respond with 2 here. So if it responds with anything more than 2, then we've got 1 more that we need. And we want to pop the oldest one out of here. So one thing that you can do with lists is pop them. And this will, if you don't give it a argument, it'll give you the last thing of it. And that actually removed it from the list. So so you see that 5 has completely disappeared. But if you want to get rid of a specific one, you just give it its position. So if I want to get rid of the first one, I give it a 0. And it gives us the 1. And now my list is 1-less. So we want to do the same thing up here, where we're just going to pop whatever is the first thing. And we don't actually, oh wait, we do actually need to keep track of this, because we're going to need to also remove the file. So old cache is equal to this. Yeah, now we need to make sure that we delete any additional files that we've created. So let's add a, this probably doesn't need to be asynchronous. Remove cache. I guess we can just stuff the whole old cache in here. Yeah, let's do that. So remove old cache, and when it gets up to here, we'll use the shell utils RM tree, which is a recursive remove. Here we're going to ask specifically, what is the old cache's cache path? And remember that when we assign the cache path, it's taking cache / the file name _ cache time. It's not including the file name itself. So the file here is recursive to this. And if we delete this using the RM tree function, it will take out any files inside of that directory. So that's what we're doing here. I don't think we need to return anything. We'll just assume that that worked, because there's no reason it shouldn't. Now what we need to do is take this cache list, which we've made sure is only at a maximum of 2. We can set this so that the cache is now set to our new cache list. So we're basically just taking the whole list and assigning it to this new list. So that's the way we get around not having add to set in TinyMongo. I mean, this part we had to do because we're being picky about how many are in here, and we're also trying to remove files, but it's really not that much of a pain in the ass to just copy the list as a list and then append it and then put it in here. So I think we're done. Like, I think we got everything covered. Let's make sure that I'm awaiting everything I'm supposed to be awaiting. I think we're good. All right. Now all that remains is to actually use this function that we've created. So if we go back into our init here, and from Dripbox file management import check local files, we add that to our main loop here. And this should work. I want to add some feedback to let us know that it is. Let's see. So it'll let us know if it's checking a file, and let's see what happens. So it is checking background.py, and background.py did not change since, oh shit, that's right. That's going to hit an error immediately, and it didn't pass the error because we're doing the async thing where the UI isn't on front, so all the errors are kind of hidden from us. Let's throw in something here to let us know if there are errors going on. So we'll do a little try except here. Exception as E, print the repr of E. So if any part of this specifically has a problem, we'll know about it, hopefully. And it should give us an error. Yeah, cache modified isn't in the database because remember we had this old file in here. So let's clear out our database for a few things here. Actually, let's delete the old file here, and we'll just we'll just blow up the database. All right. So we save our password. Let's make a new cache of background, and let's see if it. Oh, shit! I forgot to do the actual looping. So this should be a loop because we want this to continuously happen. Remember with our UI, we're making it all a loop, so it's always looping through. We need to be doing the same thing here. And I'm glad I caught that now. So while true, always be doing this. And at the end of going through all that, we'll do a await async IO sleep for, this should probably be like maybe closer to 10 minutes than 10 seconds in the real world, but since we're doing a video here, let's see results faster. So we should see in 10 seconds this pop up with another checking background. Let's thank God. So that meant that all of this worked. Maybe. Let's see. Let's change this file now. Add some garbage here. Oops. I did not await the get hash here. Oh, damn. I know exactly where this is. It's I don't know, it seems weird to me to do this awaiting inside of ifs. For some reason, my brain just doesn't get with that, but I needed to do an await here. So let's try this again. Oh, it's complaining now that this garbage I put in there isn't good Python. Okay, so it does recognize that this has changed now. The hash has changed. Did it create? Yes, it did. It created a new file here. So take note of these numbers, okay? So this one is 0.462 and this is 0.327. If I change this again, it should get rid of this one, I guess. Yeah, this one. This one, 716462 should disappear here. So it's changed. And if I come back here, it did disappear. So it's correctly removing our old caches and creating new caches. Oh man, I'm actually really amazed that my only mistake was not awaiting in that if, because this is a lot of complicated shit I've just been doing live on video here. I've had to edit this a lot because I'm getting dry mouth from talking so much. But this worked. Like if we look at our database here, I keep clicking on database to see our database. We have like these caches with their cache hashes and their cache modified. Like it's all happening. I'm really pleased. I'm going to stop here before I break anything. Thank you very much to my patrons for making these videos possible, and I hope that more people will join them, and I hope this video has been helpful. Take it easy, folks.